What's up, guys? We are back with lesson 11. Lesson 11, again, is dealing with systems of equations, but now we have to solve them either algebraically or through elimination. This is a very challenging lesson, and we definitely spent a lot of time on this. So what I'm going to do is I'm going to model two problems. I'm going to model one on my own, and I'm going to model number one from the multiple choice, and hopefully that can help you guys with your work through the rest of this chapter. So let's look at this first example. I kind of took this from the open-ended for number 8, or excuse me, from lesson 10. So we want to solve this system algebraically, and the faucet's going on. So what I'm going to do is I'll take a look at what I have here. I know I can solve this using something called equal values because both equations have a variable by itself on one side of the equal sign. Notice, both the y is by itself on both sides of the equal sign. So what I'm going to do is I'm going to take this side of the equation, this 2x plus 16, and I'm going to set it equal to this side of the equation, 4x plus 8. Again, the only reason I can do this is because they're both equal to y. That's the only way I can do that. From here, I'm going to just solve for x. I would subtract 2x from both sides. I'm left with 16 equals 2x plus 8. And then to get the variable by itself, I subtract 8 from both sides. I have 2x equals 8. Divide by 2 on both sides to get x equals 4. Awesome. So I have x equals 4, but you need to think to yourself, am I done yet? Do I have a coordinate? No, because I only have the x. So what we need to do is choose one of the equations to substitute this 4 in. I'm just going to choose the top one because no real reason. Y equals 2 times 4 plus 16. So y equals 2 times 4 is 8 plus 16, and I know 8 plus 16 is 24. And therefore, my solution to this system of equations would be 4, because that's my x value, comma, 24, which is the y value. And that is how we solve one with equal values. Now, you might be asking, well, why didn't he use y equals 4x plus 8? And the answer is, I could have, and I still would have gotten 24. If you wanted to use that on your own, you could have used, or you could do that as well. Now, I want to go into number 1 on the multiple choice and what that looks like. We have 2x plus 3y equals 14, and 7x plus 5y equals 16. Well, first off, we can't do what we did over here because a variable is not by itself on one side of the equal sign. Now, the next thing I want to do, or the next thing I notice, is that all the variables are in line and the constants are in line. So that tells me that I can use elimination. We talked about eliminating and changing our equations. Now, I need to look at my equations here, and I need to think about, well, what two numbers could I cancel out? I can't cancel out 2 and 7. They don't give me 0, and 3 and 5 don't give me 0. I need opposites. I need a negative and a positive. So what I'm going to do is I'm going to wipe out our y value first. I'm going to wipe out these y values first. So I need a number that I can multiply 3 by, multiply 5 by, to get them to be opposites. So I'm going to take my first equation and I'm going to multiply it by 5, and you'll see why. So this top equation, I'm going to write it down here, changes to 10x plus 15y. Don't forget this last number. Ooh, I need a calculator. 14 times 5. Actually, I don't. I can do it in my head. That's 2070. Now for this bottom equation. Again, I want to multiply something that's going to cancel out with 15. So I know to multiply 5 by 3 would give me 15, but that would be positive. To cancel it out, I need to multiply by negative 3. So 3 times negative 7, or excuse me, negative 3 times 7x is negative 21x. Again, this gets me that opposite of minus 15y, and it equals negative 3 times 16, ends up giving me negative 48. So from here, I can now eliminate, that's that word that we're using here, or the strategy, elimination. I can eliminate my 15y's. So my y's are gone. And now I can do my giant addition everywhere else. 10 plus negative 21 gives me negative 11x. And I set that equal to, this is 70 minus 48, which ends up giving me 22. So if I divide both sides by negative 11 to get that x by itself, I find that x equals negative 2. Again, a lot of work there, a lot of work. I had to figure out what I wanted to eliminate, and I had to transform my equations accordingly to give me x. Now you guys should be saying to yourselves, I'm not done yet. The last thing I need to do is find the value for y. Now here's the crazy thing. You have 4 different equations that you could substitute this negative 2 in for, and still you would find the same y each time. I could use this one, this one, this one, or this one. I'm going to use the top one because it's the most convenient to me. So I have 2, and I'm substituting in negative 2 for x plus 3y equals 14. Again, I chose the top equation. You could have chosen any of the equations to substitute into. 2 times negative 2 is negative 4 plus 3y equals 14. Well, I need to get this 3y by itself, so I need to move the negative 4 to the other side, and I do that by doing the opposite by adding 4 to both sides, leaving me with 3y equals 18. Divide by 3 on both sides, and I get y equals 6. So to finish my problem, I write my coordinate point. My x is negative 2, and my y is 6, and I am finished my problem. Guys, this is definitely going to be challenging. Go ahead through the rest of the multiple choice and take a stab at that open-ended. I'll be available for office hours on Zoom, or if you need to contact me through the phone. Please, please, please try your best. I will have a little quiz from the multiple choice on Google Classroom, so please make sure you take a look for that as well. See you guys. Hope you have a great rest of your day.